these structures, compound loading. Okay, you have to use this. You don't use this, we will be lost. Are we clear? Now, yes, sir. Because Px over A, the axial loading and alpha beta are all positive because it's pulling away. It's always tensile. Axial load is always tensile for this case. We clear? Okay. Right. Now, so now you all understand what we call bicentric and what we call as eccentric. Yes or no? Right. Now, next, we are going to look at what do we mean by symmetrical and unsymmetrical. You all learn all this in 2P, yes or no? So what do we mean by symmetrical bending? Unsymmetrical bending. I did not know then when I was taking like 2P04. Okay, let me look and let me ask you a structural question now. Now, I'll start from a new page. Now, we have loading condition number 1. Loading condition number 1 looks like this. Simply supported structure, evenly distributed load, a point load. This is our point C, our point D, and there's a point P over here. Okay. Loading condition number 2. We have a structure looking like this now. This is our point A, and this is our point B. And then we have a load doing this now. And the distance from here to here is L over 4. The distance to here is L over 4. Okay. And then both of them, so this is our X and Y transformation. And this is our rotation about Z. Okay, both are the same. And both of them have a structure, this is their cross-section view. Okay, so this is the cross-section. And over the other side, this is the cross-section. Now, I would like to ask all of you, right, which one is under centric symmetrical bending? Condition number 1 or condition number 2 or condition number 2? Any other picks? Yes. 2. Anyone else? Both of them symmetrical. Both of them are definitely centric, but which one is symmetrical? Which one? Just the first one. So there are 1 and there are 2. Any other takes? I need to really call Dr. Koshi. You all done this in 2P, yes or no? And you all forgot. Did you all forgot, yes or no? Yes? It's okay. Okay, I need to. Can you access notes from 2P04 or you cannot access notes from 2P04? Does he allow me to now can you go out on avenue to learn to flip cookie or no? Can you all do that? No? Or Dr. Koshi shut it down? You all cannot access these notes? Okay, I need to tell maybe teach you a lot. Right. Both of them are symmetrical. That's the problem. When we say the word symmetry, you think about what? Geometry. When I say yellow, you think about me. Yes or no? Right? If you didn't think about a banana man, it's me, okay? Let me tell you what, I'm yellow outside, but I'm white as blue in the inside, we clear, okay? I can't speak Mandarin at all. Right? I can't. Okay, so come on, a bit of humor on a Monday. Come on, you guys look miserable. Yeah, you're freaking don't just because miserable. But anyway, both of them are symmetrical. Okay. Now let me explain to you why. Okay, then accept me as a fact. Okay. Now this course has a lot of layers. So we are going to assume, Daniel, we are going to assume. Daniel, this is an assumption. Okay. We are going to assume that over here is the location of moment at its what? Maximum. I repeat again, at that location, that is where moment is your maximum. When moment is at maximum, this is where failure will what? Failure will occur. Okay, this is where failure will occur. Okay, and then we have, I'm going to label these points alpha, beta, I, and J. Okay, over here, I'm going to label alpha, beta, I, and J. Hey, Eugene, your I look like J, your J look like I. Seriously? And this is our point I, and this is our point what? Our point J. Okay. Now, I'm going to now draw a line. And this line is known as our centroid. Okay, that line is our centroid. I'm going to draw another line over here. This is also our centroid. How do we determine centroids? It's based on what? Geometry, right? Centroids are based on geometry. Okay, centroids are based on geometry. So for this case, we have a certain distance. This over here is your, this distance over here is your y1. Oh, not y1, not y prime, y1. And this distance over here is your what? Y2. Likewise, this distance is your y1. This distance over here is your what? Y2. Now, how do we determine stress X at point B or at point alpha? Right? Stress X at point alpha. Okay, so we are going to assume that over here, this is how our moment will act. And this is where we have compression. And over here is where we have what? Tensor. Okay. So stress X at alpha, okay, I'll write for both. Is equal to minus mz or mmax over ixx, oh no, iz multiplied by y1. Okay. Can you tell me what is at beta? Can you write for me the formula? For both x, for both left and right. Can you write for me the formula, please? What do you get? For beta is equal to what? Is it the same? Yes or no? Now let's write for beta. Or let's write for I. So I now, is it compression or tensile? Tensile. It's in tensile. How about stress X at point J? What is it equal to? Anyone? Same equation? Yes or no? It is the, yeah, it's the same equation. So for this case, when these conditions are met, the structure is under centric, symmetrical bending. Are we clear? It's, so whether it's symmetrical or unsymmetrical, okay, it is dependent on the stress distribution, okay, rather than geometry or loading configuration. So it's more dependent on what? On how your stresses are distributed. Are we clear? Okay, learn now. Okay, these are questions, are very famous technical questions when you apply for jobs, for design, for structure analysis. What do we mean by symmetrical and unsymmetrical? Okay, I'm also paid to mark some of these questions, and it's embarrassing. Are we clear? I don't need to be embarrassed. Okay, you're going to get it right. Are we clear? Now, then, what is unsymmetrical bending? Right? What is unsymmetrical bending? So now, before I go on, are we clear? Yes or no? Whatever I make you memorize is all very what? Visual. Are we clear? Nothing to do with whether is it plus or minus and then you can't remember. Then we're in trouble. Okay. We're going to look at is we are going to look at unsymmetrical, centric, okay. We are going to look at what? Unsymmetrical centric bending. So when does unsymmetrical centric bending occur? That's where the tricky part is. Okay, so when does unsymmetrical occur? Okay, so now we have a structure. Do I have enough space? I'm going to start on a new page. Okay. I hope this is like a recall for 2P. Is it like a recall for 2P or no? Right? So, but maybe Dr. Koshi don't mention what is symmetrical and what is unsymmetrical, but you all have done this unconsciously. Yeah, because if I write down the formula for you, you like, seen that, yes or no, right? So now, before I go on, have you all seen this formula before? Yes, okay. And have you all seen this formula before? Yes. Now I'm going to introduce you another situation where we have unsymmetrical bending. I know. So unsymmetrical bending occur this way now. Okay. So now we are going to draw a 3D structure. Okay. We're going to try to sketch a 3D structure. Okay, so again, I'm trying to sketch a 3D structure for you now. Hey, Eugene, really? So this is our 3D structure. Our 3D structure is built into a wall.